On June 16, 24, the Bank of Japan raised interest rates to 8%, the highest level since Ikkyo. Most economic models would predict what comes next. Investors rotate out of equities, borrowing costs bite into corporate earnings, and markets pull back.
Japan's Nikkei Ifru responded by breaking Nishuman R for the first time in history. 7 consecutive sessions of record closes, the index rose over 2% in a matter of weeks, led almost entirely by semiconductor and robotics stocks, and at the same moment the market was celebrating, Prime Minister Sanae Takaichi was unveiling a plan that may explain exactly why.
Japan is targeting 370 trillion yen, roughly Nordian Sandor trillion in combined public and private investment across 7 strategic sectors by 2030, the centerpiece AI, semiconductors, and physical robotics. The stated goal is to increase Japan's domestic semiconductor sales from roughly $1 billion today to $4 billion by 2030, a fivefold increase in 15 years.
For a country that spent 3 decades watching its semiconductor industry get dismantled, this is an audacious claim. The question isn't whether Japan is serious. The plan is too specific, the spending commitments too large, for this to be mere posturing. The question is whether Japan has actually learned anything from the last time it tried something like this, and whether the structural advantages it is now betting on are real.
To understand why this moment is different, you need to understand why the last one failed. In the 1980s, Japan's Ministry of International Trade and Industry, MINISI, the legendary bureaucratic machine that orchestrated Japan's post-war economic miracle, tried to coordinate Japan's semiconductor industry the same way it had coordinated steel and shipbuilding a generation earlier. Government-backed consortia, directed investment, and explicit market share targets.
For a moment it worked. By the late 1980s, Japan controlled roughly 50% of global semiconductor production. Hitachi and NEC were household names in chip fabrication. Japanese memory chips dominated the global market.
Then everything went wrong. U.S. trade pressure forced Japanese chipmakers to raise prices, ceding market share to Korean competitors. The government-backed alliances were slow, bureaucratic, and unable to respond to the speed of technological change. Companies like Elpida Memory, formed by Ameti, encouraged merger, burned through cash for over a decade before collapsing in FIS. Micron acquired it for $10 a fraction of what Japan had invested.
The lesson that most analysts drew from this was Japan can't do industrial policy in fast-moving technology sectors. What Takaichi's government appears to be arguing is that they drew the wrong lesson.
The Ichanushilu plan doesn't look like MITI. The critical difference is sequencing. In the 1980s, the Japanese government led and the private sector followed. Tokyo pointed at memory chips, and Japanese companies built memory chip factories. The government was picking winners in a space where it had limited technical knowledge and even less market intelligence.
What's happening now runs in the opposite direction. The private sector moved first. Taiwan Semiconductor Manufacturing Company, TSMC, the world's most important chip maker, decided on its own that it needed a production base in Japan. Its first Kumamoto factory opened in early 2004 cost $4 billion and produces look to nanometer chips. In February, 2004 finalized plans for a second Kumamoto facility, this one targeting 10 nanometer production with $7 billion in capital investment, targeting mass production by late 2004.
TSMC didn't come to Japan because of a government directive. It came because Japan has something that cannot be replicated quickly anywhere else: the materials and equipment supply chain that chip making actually runs on.
Japan controls roughly 1% of the global silicon wafer market. It holds nearly 8% of the global market for the specialized tools used to coat and develop silicon during chip manufacturing, a process called coater-developer. It supplies about half of the world's photoresists, the light-sensitive chemicals that etch circuit patterns onto chips. And in semiconductor equipment overall, Japan's manufacturers claim a 60% global market share, second only to the United States.
These are not businesses that came from a government strategy. They came from decades of precision manufacturing culture, from companies like Shin-Etsu Chemical, JSR, and Tokyo Electron building dominant positions in niche markets that nobody else bothered to compete in because the margins seemed too thin.
TSMC needs all of it. And TSMC building in Japan makes Japan more attractive to every other chip maker who supplies TSMC.
Rapidus, the Japanese government-backed startup attempting to manufacture nanometer chips, released its first process design kit to early customers in early Nissan and is targeting customer test chips by the end of this year. It is ambitious. It may not succeed, but it is being built in Hokkaido, a few hours from the world's densest cluster of semiconductor materials suppliers.
The government's investment plan is, in part, subsidizing the infrastructure that surrounds all of this: power grids, water treatment, talent pipelines, logistics, not telling individual companies what products to make.
But semiconductors are only part of what Takaichi is betting on. The second pillar is what Japan's Ministry of Economy, Trade and Industry is calling physical AI.
Physical AI is roughly artificial intelligence that operates in the physical world: robots, autonomous systems, industrial machinery that can adapt to its environment in real time. Think warehouse automation, construction robots, surgical systems, and elder care machines. Not the kind of AI that writes emails, but the kind that welds a car door or guides a laparoscope.
METI has stated that it wants Japan to capture 30% of the global physical AI market by 2040. The global market is projected to reach roughly $82.8 billion in the coming years. Japan's current share of the global robotics market already makes it a structural favorite. Japan accounts for roughly 40% of global robot production, with companies like Fanuc, Yaskawa, Kawasaki and Keyence collectively controlling swaths of industrial automation.
The Luchevord or billion Japan is committing specifically to physical AI isn't going into a government agency's budget. It flows as subsidies, co-investment, and R&D partnerships into companies that are already building the hardware.
Japan's demographic crisis, a shrinking workforce, a population that is aging faster than any G7 economy, is simultaneously the country's biggest structural problem and its biggest motivation to get physical AI right. According to the Financial Times, Japan's robot density in manufacturing already exceeds 400 robots per iman workers, nearly double Germany's figure. These companies have not just the financial incentive but the domestic market pressure to solve automation problems that most countries won't face for another decade.
So here is the Japan factor. Japan is not trying to out-innovate the United States in AA software. It is not trying to out-manufacture Taiwan in advanced chips. It is betting on something more specific: that the physical infrastructure of the AA era, the materials, the equipment, the fabrication tools, the robots, will be controlled by whoever controls precision manufacturing at scale.
If you need to build an AI data center, you need high-bandwidth memory chips. Those require silicon wafers from Shin-Etsu Chemical. You need the coater-developer tools that etch the circuits. Tokyo Electron supplies about half of those. The photolithography equipment needs Japanese photoresists. The inspection tools that verify whether a chip worked are, in many cases, made in Japan.
Japan doesn't need to build the AI, it needs to remain the layer of the supply chain that cannot be eliminated.
In the 1980s, Japan tried to lead the race by picking the winning product. It failed because products change faster than governments can adapt.
In Marseille, Japan is trying to own the process, the precision manufacturing capability that any winner of the AI race will have to buy from Japan regardless of who wins. It's a different theory of competitive advantage, and it's one that, given Japan's existing market positions, is considerably harder to dismiss.
The risk is real. Japan's public debt stands at 2% of GDP, according to the OECD's Nisen Economic Survey, the highest in the developed world. The Bank of Japan just raised rates to their highest point in 3 decades, meaning the government's borrowing costs are rising at exactly the moment it wants to spend Nikkei trillion. Execution has historically been Japan's weakness, not ambition.
But the window is also real. The AI build-out is happening now. The factories that will supply it are being chosen now. If Japan can lock in its position as the indispensable materials and equipment supplier over the next 5 to 7 years, the question of whether the Takaichi plan works becomes somewhat less important than whether the underlying structural bet was correct.
If you want to follow how that bet unfolds, subscribe to the Japan Factor. The Nikkei is telling you what it thinks. The harder question is whether it's right, or whether Japan is about to repeat a very expensive mistake with a different acronym on the door.